Thanks, Connor. Welcome, everyone. Good morning, good day. I realized this timing was designed to try to cater to people from different parts of the world. So I hope it's useful. Um, I'm Ali Hamade. I serve as Deputy State Epidemiologist at the Oregon Health Authority, and that's the health department for the state of Oregon. I'm also a toxicologist by training. How do I move the slides? Oh, um, okay. Before we start, I want to make sure that you understand that the views expressed throughout this presentation are mine alone and do not necessarily reflect those of the Oregon Health Authority or the state of Oregon. So the purpose of this work, it's really for the public health, and that's what our work as a health department and the public health division is concerned about. It's is the public safe? Are they are they exposed to unsafe levels of contaminants? We want to make sure that they're safeguarded while ensuring that they're getting all the benefits and living their lives to the fullest. So this project came about shortly after EPA proposed some reference doses for various PFAS chemicals. And they were fairly low, and we started looking and found that if we applied those as is, they would be pretty restrictive for some fish consumers. So we realize we need a different approach. We can't just use those numbers, which are not designed for fish consumption in mind. And just to give you a brief kind of idea of what it takes to recommend an amount of fish for consumption, you need mainly two components. One is the reference dose, and that's what EPA developed and what many other agencies developed on their own time with their own methods, which is basically the chemical exposure concentration per body weight, below which no adverse effects are health effects are expected. So above that doesn't mean there are health effects, but the chance or the risk increases. The other component is, well, how much of the contaminant is in fish? So by that, you could start comparing, okay, does this have too much chemical or less chemical, etc., and what is safe? So these are two essential components to make these recommendations. And you can see this is a general equation. We won't go into any calculations or equations in this presentation, but you can see to develop a recommended meals per month, you really need a body weight of the person or the population, whether it's pregnant women, children, etc. And you need that reference dose up on the right and the concentration in the fish down below it. And you can see it does not factor in any of the benefits that have been found from fish intake time and time again. Just an outline so that you know what to expect for this presentation. First, just a brief overview of the sources of PFAS and exposure. And then the studies used by EPA to develop these reference doses, or the doses below which no adverse health effects are expected to the general population. And they generally focused on 4 health endpoints. After that, we will go into the individual health endpoint discussions, and we'll present first the PFAS studies used by the EPA for that endpoint. We're going to focus on PFAS and PFOA. We realize there's so many, potentially thousands of PFAS. But these are the chemicals for which we have the most toxicology and epidemiology information. They're 2 of the most prevalent and most detected in humans and at the highest concentrations. So it's a proof of concept, and of course, there are potential additive effects or whatnot. After the PFAS studies, we will look at the PFAS meta-analyses and see do those, when you pool several studies together, do you still see the same effect? Then I'll talk about fish intake studies by endpoint. So I compare those studies for PFAS health effects and then see, well, just fish, regardless of contaminants or whatnot, what are the health effects of just eating fish? Then there'll be just a slide to a brief survey of some of the studies that measured contaminants, PFAS in fish, and then some needs, conclusions, and recommendations. So brief overview, this is from an EPA document that shows some sources of PFAS. On the upper left is drinking water. It could be an important source for those who have some serious contamination in their water. Otherwise, for most of the population, it probably accounts for 10% or so of their overall exposure to PFAS. You have waste sites that release some of these PFAS, fire extinguishing foam, or sometimes AAAF. That is one of the major contaminants across the country. Different occupational exposures with chrome plating, electronics, paper manufacturing, etc. Consumer products, stain or water repellent, non-stick products, food packaging, biosolids, especially a concern with the uptake from plants and whatnot, and food, whether it's fish, chicken, beef, and it really depends on the sources that they feed upon. Just to show you the potential contribution of fish and shellfish in terms of PFAS to our exposure, this is a study looking at NHANES data, and NHANES is a database, a biomonitoring database that's a fair representation of the general US population. And you could see for the different PFAS, you have, if we just focus on PFOA and PFOS, there's an increase anywhere between 5 and 20% after a month of eating seafood. That's basically the contribution to our exposure. You could see here PFUDA on the far right, that goes up to 30-40%. Luckily, that is detected at relatively low concentrations in the population's bloodstream. So fish, you might see those effects. For adults, the main exposure tends to be food, unless you live in a seriously contaminated area. Adults tend to get most of their PFAS from food. Children, probably mostly from dust because they're closer to the ground. They have hand-mouth behavior, which could contribute to increased exposure from PFAS in the dust. And babies, of course, probably breastfeeding delivers a large amount of PFAS to babies. Not that women should stop breastfeeding, it's just a considerable source of exposure, and many refrained from cautioning against breastfeeding because of the tremendous benefits associated with that. And to give you an idea about the changing exposures, again, from this NHANES biomonitoring database, if you look at the concentrations of the 4 most detected and some of the highly detected PFAS in blood, if you compare 1999, 2000 to the 2017, 2018 period, you find that PFAS decreased about 86%, PFOA 73%, PFHXS 50%, PFNA 25%. So there have been tremendous wins throughout the past 2 decades in that realm. Doesn't mean the work ends, and there are so many other PFAS that need more monitoring and more toxicology and epidemiology studies. So now we could move to the critical endpoints and studies that EPA determined were the most representative or that had the moderate to high confidence in terms of evidence. This is just a general overview of these studies, and EPA had four health endpoints: lower birth weight, um, lower vaccine antibody concentrations, and higher total cholesterol associated with increased PFAS in blood. There was a fourth endpoint, liver function enzymes, but the candidate reference doses were higher than the ones here. And just for brevity, I will not discuss that in the presentation. I will focus on these three other endpoints. And you could see the numbers, the reference dose for PFAS was 0.1 nanogram per kilogram day, for PFOA 0.03, and EPA went with the lowest and most precautious numbers. So first, birth outcomes. You could see in black the studies that EPA selected, and they found an increased with increased maternal PFAS. They found a decreased birth weight in the children. For example, that first study with both PFAS and PFOA, however, only for girls and not in boys, they found decreased birth weight. SAGIV, same thing, even if it didn't always achieve statistical significance at 0.05, they still saw decreases. Darrow, same thing, decreased birth weight with both PFAS and PFOA. When you look at the meta-analyses in green below, you see that that was confirmed as well when you pooled different studies. Now, when you look at the fish intake meta-analyses, where just different maternal fish intake studies pooled together, you saw an increase in birth weight in contrast to the decrease with PFAS. Now, other birth outcomes, when you look at the PFAS studies, they saw increased odds of small for gestational age, which is birth weight under the 10th percentile. Increased odds of preterm birth, which is gestation lasting under 37 weeks. And the third study just didn't show any association with preterm birth or low birth weight. The PFAS meta-analyses, it's important to note that the timing of blood sampling was a factor in the magnitude of the birth weight decrease. And some people suggest that's related to blood volume, etc., or other factors. When you look at the fish intake meta-analyses, mothers who ate more fish had children with lower odds of small for gestational age, smaller odds of preterm birth, and smaller odds of low birth weight. And when you look at the size, maybe the magnitude of the change, maybe one of the easiest ones to focus on is that from SAGIV, that second study, where it's a change per 1 nanogram per mil increment in maternal blood. And they saw for PFAS, it was a decrease of about 1 gram, PFOA a decrease of about 5 grams. And if you look at the meta-analysis, it's kind of similar. For PFAS, it was a decrease of 1 to 5 grams, PFOA 10 to 19 grams. In contrast, when you look at the fish studies, one meta-analysis by Leventaku showed that eating fish 3 times or more per week versus those eating fewer than 1 time per week had a 15-gram increase in birth weight. So you can see the contrast here between, okay, PFAS decreases, fish increases. And to show some nice graphs from some of the meta-analyses that kind of show a dose response, you look at maternal seafood consumption versus the odds ratio of preterm birth, you see a sustained decrease in the odds of preterm birth. And it plateaus around 60 grams per day for maternal seafood consumption, but it doesn't really go up until the maximum assessed of 80 grams per day, which is considerable. 60 grams per day is about 40 grams, 400 grams per week, 80, more than half a kilo, more than 2 pounds a week. So it's pretty permissive and actually shows benefits. Now, when these authors looked at fatty fish consumption, you see a slightly different curve where there is increased risk with higher consumption. And if you take that upper bound of the curve, it's about 36 grams per day. If you take the central estimate, it's about 63 grams per day. So if you're trying to make a decision or risk management approach to what is safe, what's acceptable, you could go with either one of those, depending on the population. But it also suggests that fatty fish might have something else in there as compared to combining all the fish. Now, what we ideally want to do is combine these PFAS studies and account for fish consumption, because we see that, okay, PFAS by itself, lowers birth weight, fish consumption increases birth weight. And here, this is one of two studies that I could find. If you know of more, I'd appreciate if you would share them with me. But this is by Jennings 2020. They use the same cohort as Wickstrom, one of the studies used by EPA, and it's a Swedish cohort. If you look at the blue line, that's just PFAS. When they accounted for some of the fish consumption, the slope of that curve changed from minus 120 to minus 48. And that's based on eating more than 0.35 times per week of freshwater fish versus those consuming less. Now, it's not fully, they didn't account for all the fish, and they had relatively low fish consumption in this cohort. Nevertheless, you saw that the fish intake modified the PFAS association. And we need more of those studies. The other study here, Lauritzen 2017 from Norway, didn't find any effect with or without fish intake. So nothing from PFAS, nothing from when they factored for fish. But again, they had lower concentrations of PFAS in that study. And just there are several other studies that show the benefit of diet, sometimes fish, sometimes fruit and vegetables, encountering contaminants. For example, this study by Taylor et al. Looked at maternal mercury exposures versus birth outcomes. And when they looked at all women, they found an association of minus 3 grams, not significant. When they looked at fish eaters, minus 1.5 gram in birth weight, again, no change. But when they looked at non-fish eaters, they saw this 58 gram decrease in birth weight. So again, suggests that just taking it at face value, eating fish really was protective against some of that mercury effect. And there are other studies that have shown fruit, for example, or fish that counter the effect of smoking on birth weight, or maternal BMI even. So to summarize the birth outcomes, there were adverse associations between maternal PFAS exposure and birth outcomes. Maternal fish intake was associated with higher birth weight and lower odds of small for gestational age, and different birth outcomes. Now, I don't present it here, but there's more data in this white paper that I have a link to in the end of the webinar. There are few exceptions with consumption of lean fish, large oily fish, and shellfish. And in some studies, there were adverse effects related to high PCB or mercury content. And frying the lean fish might have contributed to the adverse outcomes, as several have hypothesized. So now move on to the second of third endpoints, cholesterol, cardiovascular disease. And again, you see this endpoint, EPA selected total cholesterol. And when you look at the EPA studies, you see that for both PFAS and PFOA, there was an increase in total cholesterol with increased PFAS in blood. When you look at the meta-analyses, this is confirmed. Fish intake meta-analyses, there were mixed results. Other health outcomes, you see one of the studies, Dong, did not investigate cardiovascular disease outcomes. Steenland, however, found no association with cardiovascular disease, and this is a large cohort with high exposures, mainly from water. The PFAS meta-analyses generally found mixed associations. Some found adverse effects, some found beneficial effects, and some just found no effect. So it's not really something consistent. Now, when you look at the fish intake meta-analyses, and that's probably why the American Heart Association recommends regular consumption of fish, these studies found generally decreased risk of coronary heart disease, heart failure, myocardial infarction, and stroke, and often increase in HDL cholesterol, the good cholesterol. When you look at the magnitude, you look at Dong, for example, it's easy to look at the unit increase. So per 1 nanogram per milliliter PFAS in blood, the authors saw an increase of PFAS of about 0.4 milligram per deciliter, PFOA at 1.5, and this compared to a median of about 190, 195 milligram per deciliter. Steenland, for the lowest to highest decile, there was a 11, 12 milligram per deciliter difference. However, this exposure spanned hundreds of nanograms per milliliter. The meta-analyses confirmed that per interquartile range of exposure to PFAS increased about 2.6, PFOA at 2.1. So you can see there were small changes in total cholesterol, no effect with cardiovascular disease, and you see with the fish intake, there were just really good benefits on the bigger outcomes. Again, from one of the meta-analyses showing a dose response with the cardiovascular disease mortality risk and fish intake, you see with increasing fish intake, there's a decrease in relative risk of cardiovascular disease mortality, and up to 100 grams per day, even the upper bound of this curve does not go above 1, which is kind of the neutral, or anything below 1 is not associated with increased risk. Another meta-analysis that looked at coronary heart disease and fish intake, they looked at coronary heart disease incidence and mortality. On the right, you see mortality, and you see a sustained decrease in that mortality risk from coronary heart disease. And it goes up to maybe 180 grams per day with sustained benefit even. When you look at incidence, you see a central estimate sustained benefit. However, at maybe 160, 170 grams per day, you start seeing an increased risk for the upper bound. Again, this is something to be used for risk management and for making recommendations. But generally, you see a decreased risk of coronary heart disease with increasing fish intake. And we're talking a lot of fish here. The third one, and it's interesting to add, this is cardiovascular mortality and fish intake, and Jaidi and colleagues looked at Asian studies versus Western studies. And Asian, there are only 3, Western only 4 studies in the meta-analysis. And you see, in general, on the left, there's mostly, a sustained benefit for over 100 grams per day. However, for the Western studies, you see an increased risk, more of a J-shaped curve with increasing exposure. And the authors hypothesized that this might be due, though they did not have data for that, but they have hypothesized it might be due to the way fish is prepared. maybe more frying, maybe more breading, but this is really all hypothetical in the Western countries, and maybe that's why there's this association. They thought maybe there, mercury could be a factor, but then they found that fish in Asian countries tend to have higher mercury concentrations. So that hypothesis wouldn't be viable. But it's something to be studied more, maybe with more studies, different studies. To summarize the cardiovascular outcomes, there are associations between PFAS exposures and increased total cholesterol, LDL cholesterol, the bad cholesterol, and sometimes HDL, the good cholesterol. There's no consistent evidence of association with cardiovascular disease. Fish intake was associated with neutral or favorable cardiovascular outcomes. There were adverse associations in a few studies with intake of fried fish and lean fish. And again, this requires further investigation into, is it the fish type? Is it the preparation method? Is it the contaminant profiles in these fish? More work is needed. Third, immune outcomes. And here you can see EPA relied on 3 studies, and they looked at the endpoint of concern was a decrease in vaccine antibodies. So these children in general were vaccinated, and they looked at maternal or child PFAS concentrations, and then they looked at how those associated with the vaccine antibody concentrations in blood. And the importance is, antibodies could be one indicator of immunity, and if they're decreased, there's a suggestion that immunity is compromised. And ultimately, you would be concerned about people not being able to fight infections. So that is the significance. And you see those 3 studies, Butz, Jorgensen, Timmerman, Zhang, they all found decreased antibody concentrations with both PFAS and PFOA, even though they were not all statistically significant. However, there was a general trend of decreased antibody concentrations. When you look at the meta-analyses for PFAS, you see this confirmed more or less for PFAS, PFOA, PFHXS. This was really not assessed in fish intake studies, though. Other immune outcomes, they were not assessed in these studies, or this specific endpoint was not assessed or followed up with looking at infections. The other studies did, and there's variation in those responses. Fish intake studies didn't look at this endpoint in particular. However, there were quite a few studies showing potential benefits on autoimmune disease and hypersensitivity like asthma, allergies, etc. Very little on immunosuppression or something that could affect fighting disease. To look at the magnitude, there was generally something like 10 to 40% decrease in vaccine antibody concentrations, with various increases, whether it's a doubling of PFAS concentration 2.7 times or 1 nanogram per mil. And the PFAS meta-analysis confirmed that more or less, about 9 to 20% for tetanus and diphtheria antibodies. Those, along with rubella, were really the ones that found the most associations. So a little bit more on vaccine and variation within studies. There were some studies that found association with one antibody type, but not others. For example, Granum 2013 found association with rubella, but not measles, Haemophilus influenza, or tetanus. There were 2 or 3 studies that found no association with COVID-19 antibodies. And some studies showed increased antibodies with increased PFAS in serum, which some would look at, well, maybe that's a good thing. We don't know. But even those studies that we presented earlier, some of them had statistically significant increased antibody concentrations, some up to 35%, in association with increased PFAS concentrations. Which leads one to ask, what are the determinants for association, given this variation? Do we need more studies to kind of have more stability? Do we need to focus on, is this a vaccine or disease-specific association? Is it the toxoid strength, as some authors have hypothesized? Or is it PFAS concentration? Is it concentration dependent? Or maybe it's other factors. So hopefully in the coming years or decades, we'll find more. Just, it's important to note, I didn't go into the studies looking at whether there's increased susceptibility to infection, but I just relied, you see down here the statement, ATSDR did an extensive review and found no consistent evidence for an association between PFAS and infectious disease. So I'm going with that for now. I'm sure some would disagree, but it's something that needs further explorations. But I went ahead and looked at some of these diseases: tetanus, diphtheria, rubella, measles, especially the top three that were most associated with these adverse effects. And I looked at USA, Norway, and Denmark. Denmark, because some of the studies were conducted in the Faroe Islands, and Faroe Islands is affiliated or is a territory of Denmark. I could not get a response from WHO or the Faroe Islands Health Department as to whether the numbers, the cases of these infections were included with Denmark or not. There was no standalone Faroe Islands number. So again, if you know, if you have some contact there, I'd appreciate that, please. But anyway, you look at some of these numbers for the different, for the years 2012 to 2022 from the World Health Organization, and they're generally low numbers. I mean, just look at tetanus. In the US, per year, these infections didn't exceed 37 per year. And the Centers for Disease Control and Prevention in the US say that this was mainly in people who were not vaccinated against tetanus or had not taken their 10-year booster shot. So I'm thinking, even though some of these are fairly rare disease, or maybe they're not as infectious as they used to be, one would think if there's something as widespread as PFAS exposure, you would think maybe there would be more numbers. But again, this is just something to think about. To summarize the immune outcomes, there were associations between PFAS exposure and decreased antibodies after vaccination. There was variation among studies and by vaccine. Now, mostly decrease in antibodies, but some were increased and some were neutral. Fish intake studies generally showed favorable outcomes on autoimmunity and hypersensitivity, but there was scant evidence on immune suppression. It's important to add that several factors can affect the immune response to vaccines. Those could include sex, physical activity, nutrients, BMI, income, mood, stress, and these have been shown in different studies. There's also a nice review in Science, maybe 2 years ago, on circadian rhythm and vaccine response, and they looked at whether people were vaccinated in the morning or the evening, and it still needs more work, but there's some really interesting outcomes there, which should be something that studies looking at vaccine responses take into account. There's also a study by Welch that showed maternal blood lead and arsenic in drinking water could also affect antibody concentration. So there's so many more things to look at, and who knows, maybe we're looking at confounding, maybe we're looking at worse outcomes when you look at more than one factor. Just a brief scan of some of the studies I found on fish contaminant profiles, and these all are from the United States. They generally showed, some showed decreases in some of the PFAS over time. Some showed no change depending on the species and location. For example, if you take that top one, Stahl National Rivers and Streams Assessment for spanning 2013 to 2019, where they maintained half of the sampling locations, they found that PFAS, the most frequently detected, decreased over 50% median-wise. And you could see down here, Young, it was a scan of highly consumed seafood market products in the U.S. And they found that benthic organisms had the highest concentration, mostly probably because it settled down even after, down to the bottom of the water bodies, even after releases maybe have stopped. And then lean fish, then fatty fish, then aquaculture. And the study found some of the highest concentrations in some imported crab and clam, which again, FDA is working on that to monitor the what's imported and the safety of those foods. So what are some of the needs? We definitely need more monitoring of finfish, shellfish, and marine mammals to be able to give the appropriate recommendations. We have more on freshwater. We need more on marine and freshwater going forward. We also need tissue-specific measurements because different people, different populations will eat different parts of the fish or the mammal. Liver, blood, whatever, they might have higher concentrations. And not everybody just eats the fillet. Preparation method could be important. There are a few studies showing that preparation could decrease exposure or PFAS concentration, but there needs to be more work on that, maybe a standardized chemical analysis method. We also need studies of PFAS exposure that monitor fish intake with food frequency questionnaires, preferably with biomarkers to really ascertain that exposure. And that Jennings and Lauritsen studies are good, good starting points, but we need more, and that would be the ultimate one to account for the both risks and benefits. We also need to assess the toxicology and epidemiology of the many other PFAS, whether it's by animal studies, epidemiology studies, or NAMs, new approach methodologies, which, and many people are working on that. Brief conclusions for many of the populations, PFAS and other contaminants generally pose no net risk from moderate consumption, and we're talking 1 to 3 meals per week. Of a variety of the most consumed fish. It's not, 1 to 3 meals of shark or king mackerel. It's just based on these studies, they generally ate a mix of fish or seafood. And this is in line with several US national recommendations, which generally recommend 1 to 3 meals per week. And we're talking 4 ounces. As you could see from some of those dose response curves before, at least for these endpoints, you could really go high with consumption if you want to. And this is important for traditional societies, for example, Alaska Natives that really rely on salmon and some other fish as a way of life. It's cultural, spiritual. You also have to think, what would people replace those foods with? If you maybe substituted with some free-range chicken or, grains, or you might be doing well, but that's not always the case. The other conclusion is, epidemiology studies reviewed here have small effect magnitudes, or they do not have clear associations with health conditions, or they contrast with fish intake effects. And it's not and, it's or. So some of them showed one, but not the other, etc. When you contrast that with the fish, you get with the fish benefits, you get a different story. And public health recommendations. It's important to know that reference doses or other comparison values that determine the safety of a chemical do not consider the benefits of fish intake. For fish consumption, because of the benefits, one should consider PFAS health outcomes versus biomarkers. So, okay, what does this increase in liver enzymes, like 2%, tell me? I don't know if there's no liver disease, for example. So maybe focus more on that for the sake of fish consumption because of the benefits. If it's soil, maybe different story. And keep in mind effectiveness of recommendations, timing, population of interest. For example, if you're making a recommendation to a pregnant woman in the middle of pregnancy, stopping a fish will not appreciably change the PFAS amount in the blood or PFAS concentration, because PFAS generally tend to have years of half-life in the order of years. So you'll just be taking away the fish, especially, and that could be bad, especially because there are many benefits to the development of the fetus, etc. So you wouldn't be increasing any benefits, and you would really potentially be increasing risk. Finally, we might consider a reverse uncertainty factors. We do uncertainty factors usually to lower the dose and be more precautious. But we could look at it as a reverse one or a benefit factor where we could increase the dose or amount allowed to account for the fish benefits. That's something we're thinking about, but we have not taken actual steps to use. And I just want to leave you with this saying that always resonates. It's by Ali bin Abi Talib from the 7th century AD. And it's half of food sustains and half of it kills. And it's pretty fitting for this or so many life situations or food. One, it's moderation. And you could look at it, well, there are different components in the same food. So I guess this is an answer to Paracelsus as well. And this is my email address if you want to reach out later. And there's a link to a white paper. It's an older version from March before EPA finalized their numbers. But a modern version of this paper is currently under peer review, and hopefully we'll get it published within a month or two. Depends how things go with the reviewers. And I'd be happy to take any questions or discuss any items you would like.